Oh, good afternoon, Mr. Movin. Just tell us a little bit about your company and what you do.
Okay. My company is called Petromart, and we are involved in about three different aspects of engineering. We have a construction wing that builds process plants, gas plants, and then we have a division that does consultancy, oil and gas, and then we have a division that does trading. So I get involved in all the three because I look after the Kuala Lumpur office.
I see.
Office a lot.
I'm basically doing an interview for a career option in my life, and you are a chemical engineer, you know?
That's right.
So, just I'd like to know a little bit more about chemical engineering and at what point in your life did you decide that you wanted to be a chemical engineer?
Okay. Sometime in school, I had an unusual interest for chemistry. I found it fascinating. At that time, I didn't know that there was a engineering branch called chemical engineering. So when I went up to do my engineering, they laid the options before me, and there were various branches. I was not interested in a few of them.
I see.
I came down to mechanical, something called transportation engineering, and chemical engineering. So since I had an interest in chemistry, I thought it would be somewhat like that. So which is why I went into chemical engineering. Of course, chemical engineering is much more than chemistry, so which I learned later. But okay, that's how it all started.
Another question I'd like to ask is, did anybody actually influence your decision to become a chemical engineer?
Well, not really, no. It was a decision I took on my own.
So, how passionate were you to become a chemical engineer?
At that time, I had an interest to engineering, and I wasn't sure which branch. It was not about so much about passion. It was a cold decision about the future.
More rational.
And since I had interest in chemistry, I thought I'd rather do something to do with chemical engineering than say electrical or something like that.
I see.
Which I didn't know much about.
That's really interesting. What are some of your daily tasks and that you may undertake as a chemical engineer, and how much physics do you actually integrate into your work?
When I started my career, I was doing different kind of. I was working for a consultancy plant. It was building sulfuric acid plants.
I see.
Yeah.
Sulfuric acid.
Acid. Yeah. So at that time, I was doing detail engineering and procurement of items. So it was more hands-on. It was. I'd actually had to sit and design reactors.
I see.
And
reactors. What kind of reactors?
For the sulfuric acid, for the process. You burn sulfur, you get sulfur dioxide, convert that to sulfur trioxide.
What's the process called?
Sulfuric
Haber's
acid.
process, is it? No, that's ammonia.
No, that's ammonia. This is called sulfuric acid. Then you convert to sulfur trioxide and then you make acid. So I was doing that sizing. So it was more hands-on. I actually had to go back to my textbooks and design. But after a while, it's become more and more of management rather than. I don't get actually doing design or stuff or project management. It's becomes as you progress in your career. At this stage of my career, I'm doing more management and that sort of activity.
I see.
Yeah. So my present job involves looking at trends in the petrochemical industry and chemical industry. What's happening? What's the prices of oil? What's the prices of petrochemicals? What are the downstream products that Malaysia needs or Southeast Asia needs, and where the market is headed? How does the price of oil affect what Petronas is doing? So I need to predict all this and understand what's happening in the market, so I can take my company in those directions.
I see.
So I want to know what projects will be dropped, what projects will be taken up, what's the scenario happening 5 years from now, 10 years from now. So these things are a trend. So that is what we do right now at this stage in my career.
That's very interesting.
Yes.
What are some of the skills that you may require working as a chemical engineer?
Like I said, very early in your career, you'll probably have to have a good knowledge of design and how to design chemical plants, or how to at least manage a project that involves building a chemical plant. So you'll have to have skills of. Nowadays, everything is computerized. So must need basic computer skills. You'll need to know what are the standards in the industry. You'll have to be aware of something called American Petroleum Institute standards. You'll have to be aware of ANSI standards. All these are required. There's a gap between what you learn in college and what happens actually in the industry. There is a transition period when you have to learn all this, and for example, if you're doing not related to chemical engineering, say for example, let's say chemical engineering. If you want to design heat exchangers, for example, okay.
Sorry,
Heat exchangers.
Heat exchangers.
Yeah. So say if you have a fluid which has to be cooled down, you'll do it in a heat exchanger. Okay. And you're taught in engineering how to design a heat exchanger, but when you come out in the industry, you find out there's a software to do that. Okay. It's called HTRI, heat transfer.
So you don't technically have to use that knowledge.
You don't really, but you'll have to know what to input into the software. So which is what you learned in industry, which you learned in your college. So there is a gap there, so you need to pick up those. These are skills you'll really need, and this is a gap in the industry. This is a gap because when you come out from your college, you will know all the fundamentals, basics, but in the industry there will be certain norms and codes, and which you're not really taught in your college. So a good short apprenticeship is necessary for you to align yourself.
As a company, you also have to integrate yourself into the business aspect.
Yes.
So what are some of the soft skills that you require?
See, any career, regardless it's chemical or any other, I think public speaking skills are very, very essential.
Public speaking skills.
Yes. And the second one is an ability to put down your thoughts in short piece of paper or a presentation, to draw a basic business plan. These are things you should know, and regardless of how good you are, I mean, if you don't have a basic public speaking skills or presentation skills, it might be an audience of 4 or 3 or 50 or 100. Those skills are required. You must know that. You must know how to basic business writing, business letter writing, email drafting, all that you must know. This is severely lacking. A lot of the graduates we pick up.
You think it's lacking in the industry?
It's severely lacking.
I see.
Yeah. Social skills are essential. You cannot work in isolation. Regardless how good an engineer you are, your career will be limited if your soft skills are not in place.
I see. What do you look for when you're hiring another chemical engineer?
Of course, you must know the basics of engineering, but I don't expect a super intelligent candidate. It's very important to me if the candidate is willing to learn. Okay, because like I said, there's a gap between what you learn in college and what is actually applied. So I would expect a candidate who has the interest to stay back after office hours, or take work, stuff home and learn up the aspects related to his skill, to his work. For example, I was doing valve engineering for a long time.
Valve engineering,
which is something that is very crucial to chemical engineering, but is not taught at all in.
Can you explain a little bit about what valve engineering actually is?
For example, if you have a pipeline carrying, liquid, okay, you maybe have to isolate the pipeline at some point of time. So you need a device that's a valve. You can shut down the device. And sometimes when you have a leak, you need to shut down that pipeline, and then you have to do it instantaneously. And the pipeline could be in the middle of the desert, so you can't go there, drive down and shut down the valve. So you have automatic shutdown systems. So it's a mix of mechanical engineering and controls. Okay, so which is what chemical engineering is all about. I mean, it's more than just the process industry. So you must know what is a valve, how to size a valve, what are the various ways into which to control a valve, how do you shut it down quickly, what are the trials you'll face, things like this. Okay, which you're not going to learn in the college. So this is something that you can pick up. There's enough material lying around, but it's not something you would know. So you have to spend time after office hours reading up all this, read the technical journals, understand, and then go back and relate it to your work. So be prepared for what's going to happen the next day. So if you just turn up and do what your superior tells you to do, you're not going to progress very far. I find that a problem among a lot of graduates.
I see.
Because learning doesn't stop with your engineering.
So you want somebody who will continue to learn?
Yeah, I want somebody who will continue to learn, and I also need somebody who can take initiative. I would like someone with like soft skills who can do some marketing once in a while.
Somebody who's confident.
Yes, and they need to, even if they're not in a marketing job, they need to go and meet a client and get some drawings approved. Even there, you need to be have your soft skills in place, and how you're going to persuade the other person. And, those things are essential.
So switching gears a little bit, after high school, how many physics courses did you actually take?
I had physics all the way through, including engineering. In engineering, we had
even after you decided that you want to be a chemical engineer, is physics?
Yes, physics is still taught because when you go into chemical engineering, the subjects you have to have three basic subjects in place. One is chemistry, one is physics, and one is maths. Because chemical engineering is an integration of all the three.
I see.
Okay. For example, let me come back to a pipeline. For example, when you are talking about fluid flowing through a pipeline, okay, then you have something called a boundary layer. There is technical terms that come in, and these are all physics. Okay, Bernoulli's principle, which you talk about, is very crucial to chemical engineering.
Yes.
I need to know what is the velocity. What will happen if I increase the velocity in the pipeline? Or in a chemical process, if I increase the velocity, what happens to the process? Will the process also increase? Will it speed up or will it slow down? Heat transfer is, when you do heat transfer, for example, it's linked to the basics of physics. So you have to know physics very well. So it's one of the things you must know: physics, chemistry, and maths. Maths as well. Maths is very, very important.
Did high school and university physics affect your career choice? If so, how?
It didn't affect my career choice, but it helped me learn chemical engineering because most of the subjects in chemical engineering, which you learn at university, have a basis in physics and chemistry and maths, of course. So it's essential to know your physics, your basic physics well.
I see. How physically demanding is your career?
Initially it is, because when you are working, say as either a designer or project management, you have to visit the site many times. So it's back and forth. You'll be working in the office.
Is it very tiring?
If you're in maintenance, for example, of a chemical plant, it's very tiring because you'll be practically the whole day in the field. If you're in construction also, you're like 8-hour, 10-hour schedules in the field. It depends. If you're in the servicing industry also, you'll be traveling to a place, servicing and coming back. So it can be physically demanding. Or you can choose a career in which is not so physically demanding.
That's more like an office job.
Office job is more of just basic design, or if you're doing marketing. In any case, there are no desk-bound jobs. I don't think there's a single desk-bound job in chemistry.
So you would say it's more blue-collar job?
It is largely a blue-collar job, and as you move up the ladder, maybe it becomes. But it's chemical engineering. I think is unique. It is very hands-on, which is why you find a lot of CEOs in the world are actually chemical engineers. A lot of the companies, like GE and all, if you take the basic degree that they have, you find they have a chemical engineering degree. It gives you a unique perspective of the industry. So you must have both hands-on experience and management experience. It's essential.
When we think about chemical engineering, a lot of us think about the oil and gas industry.
Mm-hmm.
So we all know the oil and gas industry is one that will end in a few hundred years.
Yes.
So, I mean, not a few hundred years, maybe 50 plus years?
We really don't know. don't know because people.
But it is a limited resource, definitely.
Oil is a limited resource, but then again we don't know because we are discovering more and more new sources of oil all the time. So previously it was predicted that we'll run out of oil by 2030. Okay, we don't know, and there's so much gas reserves in this world that we could switch to natural gas, for example. So that is still chemical engineering. And if you are going to geothermal engineering, that is again chemical engineering. You have to wear clothes, you have to use the things around you. How do you make all this? This is all from chemical engineering. So chemical engineering has as long as humans, we need physical things around us, there will be chemical engineering. Maybe we will be using biodiesel, that is also chemical engineering. And chemical engineering is not just that. Even if you are talking about designing large flow systems, like for example, water systems, reverse osmosis, like treating water for drinking, even that is chemical engineering.
Oh, that's something new.
Yeah. So water treatment is also chemical engineering because you're treating water to make it drinkable. So there's so many fields. There are cross-disciplinary fields. For example, biotech, some of it is chemical engineering. Like if you want technology like biomedical, for example, imaging and all that is there. There's a lot of chemistry involved there. You need to drug manufacturing is also comes close to chemical engineering. So there's no end to it. Oil can come and oil can go. So if you're moving from oil, for example, say electric cars, how will the electric cars be powered? You need power plants. So you need some way to generate the power. So there will always be chemical engineering. There's no end to it.
Do you
just morph? It will be a different. I don't think oil is going to end
anytime soon.
No, I don't think so.
So there's still a future in oil.
Yes, there's still a future. Yes. It will taper off eventually. Like someone said, Stone Age didn't end because we ran out of stones. Stone Age ended because human beings found something, a different technology, a disruptive technology came about. So when you have some other technology coming in, which is very cheap, and it replaces oil. Could happen, but again, it's not going to be a sudden transition that's going to happen by 2030 or 2050. I think for the next century at least, I don't see oil getting out of our economy.
But do you feel the industry, in terms of the number of chemical engineers out there, do you feel it's too saturated nowadays?
If you come out with a basic degree and expect to find a job, I think it's going to be difficult. You must have a certain degree of specialization. Look for specialization, and maybe environmental engineering is also a discipline in chemical engineering. If you're looking for management side, you do a management course, that helps. If you can mix computers and chemical engineering, then you can model large systems on the computers. You can model whole chemical processes on the computers. Chemical reactions can be modeled. I found an application when I was working in my second or third job, that I was designing a filtration system, which is not exactly chemical engineering. But when we got down to modeling the filtration system, I found applications of chemical engineering. We were using fast Fourier transforms, and we were using the stuff that I had learned as tools in my chemical engineering. So if you're willing to look into these areas, I think there's a lot of scope. If you're just coming out with a basic degree and expecting to find a job, like there are 1,000 other people, but you should look for an area of specialization, what interests you. I think that's where career guidance matters. It should come from both your professors and people in the industry. So colleges should go to the industry, get people from the industry to come and talk to the students and find out what kind of jobs are available. Or maybe they don't know the whole scenario, but they can talk about their job, and that will give an idea to the students of what to do.
Mr. Movin, oil prices are dropping drastically. Mm-hmm. As a chemical engineer and someone involved in the oil and gas industry, can you tell us a little bit of why actually the oil prices are dropping so drastically?
See, you have to understand that oil is essentially a commodity. Okay, it's like tea, it's like coffee. It's not a manufactured item like say an iPad, for example, where you can command a premium to it. Oil goes by supply and demand, and if you know how the oil industry works worldwide, there is a cartel, OPEC, which controls a bulk, used to control a bulk of
OPEC.
the OPEC,
Yeah.
oil petroleum exporting countries. Saudi Arabia is one of the major countries there. What has happened in the past 15-20 years is that the hold of the cartel has been drastically reduced. Russia came up with major supplies. We've had a lot of small.
Was Russia part of the cartel?
Never.
No.
Never. And we have a lot of African countries, Equatorial Guinea, both, and countries like that which are producing oil. And one of the biggest changes that happened in the oil industry was the introduction of fracking.
Fracking.
Yeah, which came about in the US about 6, 7, 8 years ago.
How does this fracking process actually work?
Fracking, what happens is that when you say you have oil underneath the rock, right?
You're talking about shale oil, is it?
Yeah, shale oil. Yeah.
Shale oil.
So essentially, you're breaking the rock there and helping the oil flow out of this. We knew that the oil was there, but we didn't know how to get it out. So we have new processes of fracturing the rock below and letting the oil.
This is a very controversial process.
It's a very controversial process. There have been it requires huge amounts of water, which gets polluted, and there have been instances of earthquakes being triggered off.
Earthquakes.
Yes. It's a very controversial.
So it causes seismic activity.
Because you're essentially fracturing the bedrock, right? So it does cause tremors and earthquakes, and there has been linked to that, and it's been proven. So it's very controversial, but it's also very, very lucrative because oil was something like 110, 115, which is artificially kept there. Oil should not have been 150, $120 a barrel. The cost of Saudi Arabia can produce a barrel of oil in something like $5 to $15 per barrel.
A barrel of oil.
Even if you go deep sea, I mean like offshore, you can do it at $30, $35 a barrel.
And we're selling it for about. Selling it for about $60.
No, now it's selling for anything from 45 to 55. It's changing depending on what kind of grade of oil it is.
Yes.
It changes dramatically. I mean, if you have a light sweet crude, it could be 55. If you have heavier crude, it could be 50, 45. But what I'm trying to say is that it was artificially kept at 110, 115 thanks to the cartel, and thanks to everyone. Okay. Then see, commodities go through a cycle. The commodity cycles are long-term cycles. They are 10-year, 15-year cycles. Okay, so the pricing remains similar pattern for about 10-15 years, and then supply catches up with demand. So when your dollar, when you're selling a barrel of oil, say about 100, 150, it becomes lucrative. You want to take a marginal field, okay, where the production cost is around 35, 40, and pump out oil and sell it at 120. You're still making a lot of money, right?
Yeah.
So that is what happened. A lot of marginal fields came up.
Isn't it more expensive to produce shale oil though?
Yeah, it is. It can be anything from $25 to $40 a barrel. So, but still, you're selling it at 110, 115. Why not? So that's what happened. So they started dumping the oil in the market. Everybody is releasing. US is making, I think, more oil now than Saudi Arabia. So you have a glut in the market. Demand in Europe has dramatically dropped because the European economy is doing very badly.
Yes.
China has cut down its growth forecast because they have reached a kind of plateau where they're not talking about 10-12% growth anymore. They're talking about 6 to 7% growth. So where is all this oil going to go? So suddenly you have a commodity cycle in which the demand has
exceeded.
The supply has exceeded the demand.
Yeah.
This is basic economics. There is no rocket science in this. And people are talking about a lot of conspiracy theories.
Politics.
It's nothing. It's rubbish.
It's just the demand has exceeded. The supply has exceeded the demand, basically.
Yeah, and this is a long-term cycle. Commodity cycles are long-term. So these prices are going to remain for some time.
I see.
Okay.
How long roughly?
Commodity cycles can go on for 10-15 years.
Wow.
Yes.
So we can look at cheaper oil for 10 to 15 years?
You can look at reasonable oil for the next 10 to 15 years. I won't say cheap because what's going to happen now is that at 50, 55, a lot of the marginal fields will stop producing. They will no longer go in for investment in marginal fields or offshore, deep shore, deep sea oil, which all is expensive to. Your cost will be $40 a barrel or so. So, no point you do it at 35, 40 and sell it at 45.
Yeah.
So those kind of people not go for investments anymore. So again, this whole demand supply cycle has to align itself. So it's going to take some time. I would expect maybe not 10-15 years, at least for the next 5-6 years, I would expect the oil to be $55-$60 a barrel, maybe 65, around that. But it's not going to go back to 110.
Wow, that's interesting.
Yeah. You understand how it works, right?
Yeah.
This is a commodity. Some people are making this commodity at $15 a barrel, some people are making it at $35 a barrel.
Yeah.
And countries like
so there's no politics, no.
There is politics involved because for a long term the OPEC was controlling the prices, and Saudi Arabia does not want it's counterintuitive, but Saudi Arabia doesn't want oil to go at 80 or 90 or 100.
Yeah.
Because then the marginal fields will come up, which is exactly what happened. Now you have so many producers that you cannot, once you're pumping out the oil, you cannot store it forever, right?
Yeah.
So you've got to sell it. So you will sell it at any price that you get. So instead of getting a reasonable price of 65, 70, you'll have to start dumping it at 45. It hurts countries like Saudi. They would like a nice price of 60, 65.
Yeah.
Okay, everybody would be happy with 60, 65, 70. At least the big producers like Russia and Saudi and these countries. So this is the scenario. There's no conspiracy theory in this. It's simple demand supply.
I see. Switching back to the idea about chemical engineers.
Yeah.
How does the market look like now? And if I were to graduate today, are there jobs for me?
If you're talking about Malaysia is investing almost $20 billion in
$20 billion.
$20 billion in a massive petrochemical complex in Johor, not Johor. There are jobs available, and there would be a problem in countries like USA, because now they will be cutting down on fracking and a lesser number of jobs. But like I said, there's always jobs in allied fields, petrochemicals. So I don't think it will be difficult to get a job
as a chemical
engineer. Not in the next 5 years, not in the next 10 years.
What about, say, the next 10 years, 15 years, 10, 15 years?
I would still say there's a future for chemical engineering.
So it's an everlasting field?
It's an everlasting field. It's not going to go away. Because
like you mentioned earlier.
Yeah, it will morph into something else. So if your skills are in place, you can always retrain yourself and find a new job which is related to chemical engineering. Your basics will always help you.
So another question is, did you find it challenging to become a chemical engineer? Are there any challenges you faced at all?
Chemical engineering initially was fun in the first 2 years. After that, it got into very difficult maths, which I'm not really good at. So I did struggle with my chemical engineering.
So the mathematics
I found it very challenging, because when you go to study chemical reactions in detail, this is chemistry, high level chemistry. It's essentially maths. It is second order, third order differential equations you're applying. So you're applying fast Fourier transforms, which is quite advanced math. So I found it difficult. I think all of us found it difficult.
So anybody will find the mathematics component?
Yes. If you're going to go into chemical engineering, make sure that your mathematics is very, very strong.
Okay.
You have to be wary of that. But it was fun. The chemical engineering part, the process part of it, how various chemicals are made, it's very interesting. Something that I always enjoyed, so I passed out. Where I found a problem was when I came into the industry, and there's a big gap there between what is there in the textbooks and
because you had to learn.
Yeah, you have to learn a lot.
What the business requires, right?
Yeah. I remember the first day of my job, and my boss asked me, "Do you know the difference between a pipe and a tube?" Okay, I didn't know the difference between what's the difference between a pipe and a tube. You're not taught what's the difference between a pipe and a tube in this one, or how a simple pump is to be
What's the difference between a pipe?
It's got to do with it's a little complicated. It's got to do with how they are specified. A pipe has something called a nominal bore and a schedule, and a tube has got wall thickness. This is quite complicated, which you'll learn later. Same thing with pumps. He says, okay, this is a small, simple chemical process. It's a pump required. How to specify a pump? You know there are different kinds of pumps, but you don't know for this application should I use a reciprocating current, should I use a centrifugal pump, and what should be the line size? And you don't know. These things that you're not taught in engineering.
So you have to learn on the job.
Yeah, it was like, I think what effort I put in 4 years of chemical engineering, I had to put in the first 2-3 years of work.
Wow.
All over again. And it meant sitting up late and sitting with other people, learning how to do things.
I see.
Yeah. And also, because a lot of stuff is done, you're not physically drawing, everything is on CAD.
Yeah.
So you have to understand the basics of how CAD works, because you've got to explain to the draftsman what is required. So you have to know a little of it yourself. Yeah. And you're not taught CAD in I don't think
university.
It's university. I don't know if it's taught now. In our age, it was not taught. And computer skills, we were severely lacking when we came into the industry. A lot of, even as far back as 1989, there was already the heat transfer calculations.
And when you were coming into the industry, it was more, they were just integrating computers.
Yeah,
right?
they were already there. The industry was already using computers.
Oh, I see.
Yes. But we were not.
This was the 1990s.
I'm talking about 1988, 89, yeah. Because at the time already there were distributed control systems, for example, DCS systems, which is what is used to control a small chemical process plant. These are industrial computers. They're already there in the market. But we had no clue about it. We had no clue about it. And okay, we had process controls and all we had learned, but electronics we had not learned.
I see.
So to understand that and how it's applicable to you and how do you learn all this, it's a lot of work. I think that gap is, I don't know if it's still been addressed. I found that very challenging.
I think nowadays it's more a part of the curriculum than it probably was when.
Yes.
Yeah. Well, do you actually find your career interesting and stimulating?
Yes, chemical engineering is very stimulating. It is challenging, but it's very stimulating. It's very interesting because there's no boring moments in it.
So you still have that passion you had when you came into the industry?
I think so. I think one of the reasons I've been successful is because I still have a passion for what I do. I think that is essential for any field.
Yeah.
If you're not going to enjoy what you're doing, you're not going to be good at it.
Yeah, but there are a lot of unhappy doctors out there, aren't there?
They shouldn't be there. You're not going to be successful unless you're passionate about what you do.
That's very true. If you had the opportunity to start over, what would you choose?
I would still do my chemical engineering, but I would have continued my study. I had an issue because I wanted to go abroad to an American university and study and do my master's.
To an American university?
Yes, I got admission as well, and my problem was I didn't have enough funding. That is something I regret. Maybe I should have sought some other means and continued my study. I think it's a postgraduate degree is essential. Maybe management degree as well. These help you in your career to make your career growth faster.
So, Mr. Movin, you are a very successful chemical engineer. Do you have any tips? What is your secret to success?
I would think that the most important thing that I have adopted in my career is a curiosity for what I do, interest, a passion for what I do.
I see.
And my ability to keep learning things and to admit that I don't know and ask people how to do things. So I don't feel any shame in asking even the basics sometimes. I was designing the other day a silencer for a Silencer for exhaust system, gas turbine
okay,
exhaust system.
yeah.
And I had to go back to the basics, which I had forgotten. So I called up somebody and asked him.
Is that a muffler?
It's a kind of muffler. Yeah. So that kind of curiosity I have, which is not unique. You must tell yourself that what have I learned today? You know, so if you're going to be like some people in the industry, like some doctors who don't even know what's the latest in their field, and they only know what they learnt in college, I think that's not going to take you far. So unless you know what's happening in the field and you maintain your curiosity and interest, a passion for what you do, no, you're not going to succeed. I think that's the reason that I have been successful.
Lastly, Mr. Movin, I'd just like you to tell us how the industry has changed since you came in from until now. How has the industry changed overall?
I would say there's been more and more of control. The control systems is something that has dramatically changed. Like the basic chemical processes, they have been, like I said, I was talking about fracking. That is something new that has come about. Biodiesel. These are two processes that have come, but they're not too many. They're not too difficult to keep in track of. What's really challenging is the whole automation of the plants.
I see.
That has dramatically changed. And
so it's more like the integration of computers.
Computers and control systems, not just computers, control systems. A lot of stuff that had to be done manually is not done using control systems. Operating valves, for example, I'll give an example. It's all automatic now. How do you keep?
When you came into the industry,
it was not. It was quite a lot of it. It was electro-pneumatic, and you use the compressed air to open and close valves. Now you're using 420 milliamp signals, and that's changed dramatically, and that is challenging. That was challenging to us. I think present-day engineers will find it a lot more easier, because you know what is computers are capable about, and you're using different platforms, and for us it was a total we had to do a shift in our minds. I still know a lot of chemical engineers, the old time chemical engineers, who struggle with control systems.
Control systems.